Hello class. Hi, this is Dr. Tithi Banerjee, Assistant Professor of Department of Civil Engineering from Swami Vivekananda Institute of Science and Technology. So class, in my previous two classes, I have discussed regarding the physical and chemical characteristics of sewage and the impact of environmental engineering in civil engineering. So today I'll be discussing numerical problems of BOD and the concept or formula behind it. Okay, so let's start the class. So I have already discussed that BOD, or commonly known as biological oxygen demand, is the amount of dissolved oxygen required by microorganisms to decompose organic matter present in water, like sewage or industrial waste, under aerobic conditions. Okay, so the dissolved oxygen, the amount of dissolved oxygen microorganisms require to decompose the organic substance already present in the sewage. So the amount of dissolved oxygen, that is known as BOD. So generally BOD, uh, we there we I just want to introduce two terms related to BOD to you. One is BOD5 and another is BOD ultimate. So now I will explain you what is BOD5. BOD5 is the amount of oxygen consumed by microorganism during the first 5 days of incubation at 20 degrees centigrade. So at 20 degrees centigrade, BOD is the BOD5 is the amount of oxygen that microorganisms consumed to decompose organic material under aerobic conditions. Okay, so in case of BOD5, during the 5 days, almost 68% of organic compound can get decomposed. Okay, and what is ultimate BOD? So first I will explain the purpose of BOD5. So, what are the purposes? It is used as a standard measure of water pollution because 5 days is long enough to represent most of the biological activity. It is commonly termed as BOD5 units, milligram per liter. Okay. Example: if I say that a sewage sample has a BOD5 equal to 200 milligram per liter, what does it mean? It means that 200 milligram of oxygen are used per liter in 5 days. Okay, so what I have told you that in case of BOD5, 68% of organic matter can get decomposed. Okay, and because 5 days is too long. Okay, now coming to ultimate BOD. Now, what is ultimate BOD? It is commonly used as BODU. So, what is the definition? The total oxygen demand required to completely oxidize all the biodegradable organic material is known as ultimate BOD. So in case of BOD5, 68% of the organic compound get decomposed, and in case of BOD ultimate, the total amount of oxygen get decomposed. So that can be in case of BOD ultimate or BOD, that can be termed as BODU or BODT. So T can be 10, T can be 20. Okay, so that can be anything. Okay, so it depicts that in case of BOD10, in case of BOD10, which can be considered as BOD ultimate, in case of BOD10, so we need to know that in 10 days, the total organic compound of a sewage will get decomposed. In case of BOD20, which is which can be represented which can be represented as BOD ultimate. So in case of BOD20, which is represented by BOD ultimate or BODT or BODU, so it represents that in 20 days, the total organic compound will get decomposed in 20 days. So BODT, in case of BODT or BODU, what I have given you the example of BOD10 and BOD20. So these two examples represents that here the ultimate time is 10 days or 20 days. Okay, so we will use a simple mathematical formula to deduce BOD ultimate and BOD 5. So there is a mathematical relationship. What is the relationship? That BODT equal to, okay, BODT equal to BODU into 1 minus e to the power minus kt. So here BODT equal to BOD at time t, that is, for an example, BOD 5 can be termed as BODT, and BODU is ultimate BOD. So BODT represents at the time frame when that can be considered as BOD 5, and BOD ultimate is the time which represents the total decomposition of organic matter. Okay, so here K, the mathematical formula is BODT equal to BODU into 1 minus e to the power minus kt. E here itself represents base of log. Okay, so generally we consider E as log 10, base 10. Okay, so now I am again repeating the formula BODT, that is the time of the exact time when the BOD is getting decomposed, that is BOD 5, and BODU is the ultimate BOD where the total organic compound will get decomposed. And here E represents the base of log, that is 10, and minus kt. Okay, minus kt. T represents the time. Okay, T represents the time, and for ultimate BOD, T represents the time, and K represents the deoxygenation factor. Okay, or deoxygenation constant. So what is deoxygenation constant? The deoxygenation constant is a measure of the rate at which oxygen is consumed by bacteria in water. It is used to predict the BOD of a water over time. Okay, so the deoxygen constant is a measure of the rate at which oxygen is consumed by bacteria already present in the sewage. So what I have told you, that BOD 5, okay, equal to 0.68 of ultimate BOD, that is 68% of ultimate BOD. So this is the simple mathematical formula. Okay. Now coming to a mathematical problem. Here a mathematical problem is given that determine the ultimate BOD for sewage having 5-day BOD at 160 ppm at 20 degrees centigrade. Assume deoxidation factor 0.8 per day. So here we will use the simple formula, that is BODT equal to BODU into 1 minus e to the power minus kt. Okay. So now what are the parameters given here? From BOD 5, here BOD 5 is given 160 milligram per liter at 20 degrees centigrade. Okay. Deoxidation rate or constant equal to K equal to 0.8 per day. So by using the formula equal to BODT, that is BOD 5 equal to BODU, matlab that means ultimate BOD, into 1 minus e to the power minus kt. So BOD 5 is given. Okay, so BODU equal to will be BODT by 1 minus e to the power minus kt. So BOD 5 is given 160, 1 minus e to the power 0.88, that is deoxygenation factor, that is 0.8 per day, into time. Time is 5. Okay, so here BOD 5 is given, so we need to deduce the ultimate BOD. After calculation, it is coming 160 milligram per liter. So the ultimate BOD is approximately 163 milligram per liter, slightly higher than the BOD 5, representing the total oxygen required for complete organic decomposition. So this is one type of example of mathematical problem related to BOD. The next class we will discuss another mathematical problem. So as of now, thank you. Thank you for having your patience. Okay. Good day.